Lecture number 2. Today we discuss the NMR spectrum interpretation. This is my name is Muhammad Umar Farooq, and today our second lecture on hydrogen NMR spectrum. And this is the structure of the unknown compound. We must interpret of hydrogen NMR spectrum. This is the spectrum. This is the all over the spectrum of this structure, and this is the description of this structures, and this is the some main points that are we discuss in this lecture. First of all, we see the structure. This we first of all find out the number of proton present in this structure. There are the 5 proton are present in this structure. That show the, it means it have a 5 proton. They show the 5 signals, 1 2 3 4 5. These are the 5 signals. 5 peaks are shown in this spectrum. First we name A, this name, this proton we give name B, this C, this is the neighboring and correspond to each other, so we give the 1 C, and this is also D, and this is the alone E. This E proton has no neighboring, that's why they are not split and only show single largest proton. This is the singlet, it shows singlet peak. Now we describe proton C and D are neighbor and split each other into 2 peaks, means show doublet. This C and D are neighboring each other. This proton are split by proton C are split by D, and D proton are split by C because they are neighboring each other. And splitting rule is n+1 that I explain on the later. This shows C and D, they are split each other and they are the doublet. Hydrogen, this proton is split by this proton and show doublet, and this D proton is split by C proton and show doublet. Both this doublet and this doublet and show only one. Here is we see the doublet. This is show the 7.8 ppm D signal. This is the doublet, and this is the C. This is the show at 7 ppm. This is also doublet. Now proton B are split into the 4 peaks quartered by the neighboring 3 proton A. This B has 3 proton in their neighboring. That's why according to rule n+1, this show the 4 peaks, and this is the quartet. And next, proton B are split into 3 peaks triplet by the neighboring proton, 2 neighboring proton B. This B proton have neighboring 2 proton, and this A proton have neighboring 2 proton. Carefully understand, this B proton have 3 proton in its neighboring, and this A proton have 2 proton in neighboring, which is the B. Carefully again understand, this B proton have 3 proton in its neighboring, and this A proton have 2 proton in its neighboring named as B, as explained in this description. Now let's move hydrogen NMR spectrum interpretation. A spectrum, this is the A having 2 proton in NMR, 2 proton plus 1 according to rule n+1. This show the triplet, and this is the B having 3 proton in its neighboring, and 3 plus 1 is quartet. This is the C doublet, and this is the D also doublet, because they are neighboring each other, and they have 1 plus 1 is 1 proton is according to n is here. N show the number of proton. 1 proton means n value of n 1 plus 1. This is the value if 1, then the 1 plus 1 value 1 2. This is the 2 peaks, means show doublet. This is the E proton having no neighboring in around each other. then they show no neighboring proton, they show this only singlet peaks. Let's move some of the important functional important descriptions of to explain this structure. Functional group, number of proton, number of different types of proton, and last spin splitting. अच्छा जी, functional group present in the molecule. Functional group are always present in the functional group because this is the functional group, this is the functional group, benzene is itself is functional group. Functional group, this is determined based on the position. This is determined on based on position. ppm, this number of splitting or signal show or represent functional group of the signal on spectrum. Most often scale goes from 0 to 12 ppm. Number of proton, how many proton are present in this molecule or in this structure, represented by the each signal. This measured by the integration, which is the surface area under each signal peak. This is the number of proton come from integration, which is the surface area under each signal peak, and this is the total. For example, if we see as an example of this, show 5 proton, 1 2 3 4 5 signal are shown, 1 2 3 4 5. This spectrum show the 5 number of proton, means number of 5 signals are showing this in this spectrum. Number of different type of protons in the molecule is determined by the number of NMR signal. Only non-equivalent proton give the different signals. Chemically equivalent proton give one NMR signal regardless of their number. And last point, spin splitting, tell how many proton are connected to neighboring carbon. Spin splitting show or tell us number how many proton are connected to neighboring carbon. This is determined by the number of peaks, signal multiplicity within the signal spin based on the n+1 rule. This is all about the NMR spectrum interpretation of an unknown compound. In this lecture we discuss the functional group, number of proton, number of different type of the proton, and spin splitting. Thank you very much. If you have any question, please comment on.